Hey y'all, today we're going to talk about hypothesis testing for proportions. And I'm going to show you how to do it by hand and then with the instructor provided function that's on the R help pages. So for these, you're going to need to be able to find your p-value and your test statistic. So you'll need three things: the sample size, the sample proportion, and the null proportion. So for this example, we're going to say 60% of people vote in elections, and you sampled a group of your friends, and you found that 27 out of 50 voted in the election. So you want to see if the proportion of your sample is different from the stated proportion. So we're going to set our n equal to 50 because we sampled 50 people. We're going to set our p-hat equal to 27 out of 50 because that is the probability that someone voted. And then our null proportion, or the one that we're trying to see has changed, is 0.6. The 60% of people vote in elections. So now I want to see if the percentage of people, the true proportion, has decreased. So if P0 has decreased from 0.6 to 0.54, we'll see the probability of that. So we've defined the standard deviation of our proportion, which we find with the square root of p times q divided by n. And for this one, we use the null proportion. We use the null proportion for hypothesis testing. So we'll find our standard deviation of p. And then once we have our standard deviation of p, we find the test statistic, which all we do is p-hat minus p0 divided by standard deviation of p. So if we set all of our variables at the top, all we have to do is write this code and it will find everything for us. So our p-value of the lower is the probability that we find something with a mean of 0, a standard deviation of 1, and the number is the test statistic. So our p-value of the lower bound, that the probability that it's decreased, is 0.19. So at a significance level of 5%, that p-value, we would fail to reject the null hypothesis. So if we wanted to find the upper tail, the probability that p0 is increased, right now looking at it, 0.54 for our sample, 0.6 for our null, it probably hasn't increased, so we're probably going to see super high probability for our upper, and we see 80%. So our upper probability, the probability that it's actually increased, is very low. And for the two-tail, you'd have to double the tail probability. So the reason we have a min here is that one of these values is going to be larger than 1. So we will take the one that is less than 1 because we can't have a probability of greater than 1. And we find our p-value of two-tailed, so just the probability that our null probability has changed is 38%. So that also fails at the 5% significance level. So if you don't want to do any of this code that I just showed you, the instructors have provided you a function that is in the R help pages. So if you go to your R help pages for chapter 10, test proportions, and you scroll down to the very end, there's this ztest.p function, and you will copy this, and you will paste it into your R, which I've done right here. And when you run this function, it shows up in your environment. It's called a function. So I could click on this and it shows me the code for the function, and it does all of this code that I just showed you for you. So all you have to do is call this function called ztest.p, and it says it takes p-hat, it takes n, and it takes p0. So I will tell this function, okay, my p-hat is 0.54, my n is 50, and my null probability p0 is 0.6. So when I run ztest.p, it tells me that test statistic that we found earlier. It tells me the lower p-value that we found earlier. It tells me the upper one that we found, and the two-tailed. So the ztest.p function, definitely use this because it will save you a lot of time, and you won't have to think about what each individual line of code is doing. If you have any other questions, come see us in office hours, and good luck on your homework.